Hello, class. We are meeting once again to continue our Latex typesetting application. I believe we have gone through the first video and we have started falling in love with Latex. It's so interesting and so wonderful to use Latex. Today we are going to look at another aspect of Latex, that is the using Latex to type mathematics equations or formula or expression. It's going to get even more interesting here today. And I want you to be very serious and attentive and practice as I go on. You watch the video and you practice. And I believe the first session I presented, you have already practiced. If you look at the slide, I have jumped down, I think, three main sessions in the slide. Um, it's because of time constraints. So I would want you to follow the slides and then learn those concepts. Things like how to construct a table, how to use the itemized environment to list items, objects and non-object items, how to insert an image, how to then after this one we have the bibliography or referencing facilities in Latex, how to use citations, just like we did in Microsoft Word. We also have those facilities here that are very, very easy to handle. So I'm jumping these things and I'm focusing on the mathematics aspect. I believe that once you get the first aspect, you get this, and then you begin to learn the language, you can do the other as well. So fall on the other materials I'm giving you to do more practice. As I said, I'll give you an assignment that will let you do more, learn more and do more. So uh, thank you for following the video. So let's get in there and see how to typeset mathematics equations. First. Now, some symbols in mathematics. To illustrate the rest of this part, we will introduce some mathematical symbols. More can be found on the last few slides I'm going to show. All mathematics must appear in math mode. Let me take it again. All mathematics must appear in math mode. But more about this in a moment. So the following symbols can be produced using the command. This is just a teaser. If you want to type, on the keyboard, you don't have things like less than, greater than symbol like this. You don't have times symbol. So whenever you are saying equal to times equal to, we normally use the X character. The X character is not a times character. It is the character or the letter X. So you use it wrongly. If you want to type something like a pi or infinity, as we normally use in mathematics, you don't see these things on the keyboard, but you can get them in later. So these are the commands that you're going to use. It's less than or equal to a backslash to indicate that is a command. And then L means less, then equal means equal, so less or equal. Then the time, you just type backslash time, then it produce pi, you just type backslash pi, then it produce. So it's very, very infinity. You type backslash int, then it will give you infinity. Now, these are some of the symbols you can easily type in Latin. The more you use Latin, the more you get to know some of this and become familiar with it. More symbols. So we want to see how to type some of these things. Some symbols are used to combine other mathematical expressions. For example, how to type power. So if you this on the right hand side is the output, how you see it in Latex, and the left hand side is how you type it in the text editor. If you want to type exponent pi equals -1, then this is how you're going to type e correct or the exponent sign. Then you put it in curly bracket I backslash pi is a keyword or a command, so you have to put the backslash pi and what you want and produce it. If you want to deal with superscript, so powers or superscript, you use the character current or this symbol. So use the power symbol. So its name is actually current. And then whatever will be raised to that power is put into curly bracket. I told you earlier that the values or the argument of any command is put in curly bracket. So if you want to use the raise your power, then you put it into the curly bracket. Same with subscript. If you want a subscript like A, you are typing a Q. A subscript n plus 1 is equal to 2 times an. How do you type this to look nicely like this? You come to Latex or Latex and then you type a underscore. So underscore is used to indicate subscript. And then you have whatever you want to be in the subscript inside the curly bracket. Then 2, which is this 2 times the backslash sign a underscore. If whatever you are expressing is just one character or one expression together, then there's no operator in between. Then you don't need the curly bracket. But if you have an operator in between, then you need to bring the curly bracket. So for example, n plus 1, you need, or if you leave it that way, if you misinterpret, you group them in the curly bracket. If it is only n, you can just leave it. Fraction, how do we type fraction? Use the command frac. And then the first portion is the numerator and the second portion is the denominator. So the numerator in the first curly bracket, numerator in the second curly bracket. You are able to produce this easily. If you want to type this in there, you have to either use equation data or something like that. Very simple in Latex using Latex standard. Summation, even more wonderful. If you want to use summation, just backslash sum, then the lower limit, you use the underscore for the lower underscore into brackets, then type whatever expression that will go into the one, and then followed by a caret or raise the power, which will handle the upper limit. So in means that's infinity. Then whatever will come in front of the summation sign, this is upper bracket. We can implement these things. So let's keep going. I will switch to the environment and then we begin to try some of them. Inline mathematics. If a mathematical expression appears in a line of normal text, this is what we do. When you are typing and you see in a sentence there's an indication or expression, that is referred to as inline. In that case, if you want the LaTeX editor to recognize that whatever is coming is a mathematical expression, you have to use the dollar sign to start and end the mathematics. I'll give the example. This to ensure that lines are kept as narrow as possible to avoid LaTeX having to change line spacing. So when you do this, you need to fix it to that particular line without making portions come down to push the next line down. So let's look at an example. It has been already shown that, so this is a sentence. It has been already shown that when we are putting this series expression inside, so you begin with the dollar sign and you end with the dollar sign. A underscore n plus 1 is equal to p times A underscore n. That's the formula that we just learned. Which can thus conclude that so these are inline expressions. Inline. Because we are beginning the sentence. And this is how the output will look like. It has been shown that a n plus 1 is equal to up because p times a n feature. To do that, it has put it right, in the sentence without pushing the next line down, including something like double space between the second line and the first. We can also conclude that from this. Then we have, when I finish, I demonstrate this large formula. If the mathematical formula appear on separate lines, you start the mathematics using backslash and then the square bracket and then end it backslash. You can also use double dollar sign. Also the double dollar sign. This is to show that this is not an inline mathematics. It is rather on a different line. Example, it has been shown that blah blah blah, then you can just conclude that then this is on a different line. The backslash square bracket, then you have our expression. And you end it backslash square bracket. You open and then you end. It's whatever mathematics expression. This is the fraction. Backslash that means a fraction where this is the numerator, this is the denominator. And then this is also an inline. This is the output. So I've already shown that this is an inline expression that we can conclude that with this figure and expect over a lot of space. This is a large formula and this line. And this same formula is down here, and then inline, if you know the difference. Then we have things like equation environment. In the equation environment, we have things like the equation array. So let's go through that. So quite regularly, one needs equation with aligned equality sign. The environment is array is used for this. So you can see that we are solving like a quadratic equation, and then the solution, the equation, the equality sign, you want to align all of them. You are deriving an equation, or solving an equation, or presenting an equation, set of equations. And you want the equality sign to align so that the equation is looking at. You use what we refer to as the command environment if array, that is equation array. Separate lines using backslash, double backslash, and then the left hand side equality, you use the ampersand sign on the left and right, and so you go right. So this is a special example. We have two equations. We want to align the equality sign to be on the same line, vertically, to align vertically. So this is how we go about it. A underscore 0 means a sub to 0. The ampersand, this sign, the end sign, is its name is ampersand. So ampersand before the equal to sign and ampersand after the equal to sign. Then that comes after the equal to sign. The backslash means the next line, double backslash. So the next equation will also start. A underscore A plus uh, 1, other, then you have the ampersand, the expression continues. When you finish, because you are not moving to the next line, you jump to the double slash thing, and then you end the equation arrow. So this is what we are going to get. Now, and the equations are automatically numbered. If you want to remove the number, I'll show you how to remove it. So you see that the equal to signs are aligned vertically nicely. So it makes the presentation of mathematical equations very wonderful. Okay, so sometimes if you don't want to use bring the equal to sign, a good way here is to bring the asterisk. Alright. And then another way is to just type after this one backslash no number. I see something. Summary. Spacing is ignored in math mode. So in math mode, if you type like inline equation like this, x, y, and you create a script like this, Latex doesn't recognize it. You put them together. So it will give you the same result as this one. Doesn't recognize it ignores it. Doesn't matter the length of the script. If you need to escape from math mode, include normal text. For example, for the name of function, use the command mbox text. So, for example, you are in the equation mode, and then you want to type something that is not that doesn't require equation symbol. But once you are in the equation mode, you can use this mbox to force that particular text you put in this mbox not to have the equation mode format. For example, you have dollar and the ending in dollar meaning this is inline. So exponent and plus mbox Fibonacci and yeah, so it means this Fibonacci will not have the format of equation mode. So, never use math mode to emphasize text because if you have this math mode, it will give you something like this. And this is not the same as using the proper formatting emphasize for this one. Okay. When you use emphasize, you get it. And when you use math mode, this is what you see. Putting them up. These are some of the mathematical symbols and their commands. If you want to type alpha, this is that, and then you have and H bar that looks like this. I, math, these are, let's put the common ones that we know. Something like the partial differential equation, infinity, things like triangle, general construction, the square root, then nabla, empty set, prime, for all, this we normally use in German. For all, there is this negation, uh, many more. So the intersection we have, if you want intersection, we use the backslash cap, and then the union, we use this cap, union plus, many things. Times, dot, star, division. If you want assembly division, this is not on the keyboard. You want things like something disjunction and the liquid or and many things. Then when it comes to so they are groups, these are binary operators. The first one they are some general mathematics for you. And then this is relational operators by where down greater than and all these things found here. And then arrows implies that and then equivalence and all these things are also discussed. You don't use them, you practice with them, or you use them and they will practice. This symbol, like the formation, the product, uh, integral, all those things can also be talking this way. And the Greek letters, like the alpha, beta, gamma, delta, epsilon, beta, alpha, theta, and all that. And then we have some functions, standard functions like cos, at cos, sine, tan, length, log, greatest common divisor, maximum, minimum, and the like. So these are some mathematical stuff that we have to know. Let's go to the environment and practice some of these things. So I switch. So I switch and come to our latest environment where we last video, the previous video we did, we typed a couple of things here. We are still in here and we are going to type some mathematics stuff. So let me take a question for you and type my mathematics stuff. So I'll come down here in this same document or I can open a new one. So let me just continue with it. Come down here and type the question. This question. So you have to select by using the tab key. Yeah, I selected. I didn't finish typing. When I type the question in, let me see mathematical expression. Institution. Okay. So I will just type it. And I'm going to under that type of feature. So after typing this one, let me run it for us to see the section before I proceed. So I just click on compare. So you realize that that section, if you look at the right hand side, you can see it there. Okay, I'm just going to minimize it. So you can see the section I've just reviewed, section 1.2. I'm going to type my mathematical expression. X didn't come. So I type the X and I update it by clicking compile. So I'm running it that and so. So let me type some inline formula or inline expression. So I'm going to say the general formula quadratic equation is given as an inline is the part of the sentence. So we all know the quadratic equation. A x squared plus bx plus c equals to 0. So to make it a mathematical formula, as we have learned, I begin with a dollar sign, and then I begin to type the equation. A then x square, we use the caret. And because it is only one character, I don't need to bring the curly bracket. So if it is c plus something, or then I'll bring curly bracket to group that power. So I move on. Whether I bring space or I don't bring space, it will not, my space won't do anything. But sometimes you bring the space to make it readable. You make the code readable, not the output. So plus, let me just let it speak. So plus b x plus c is equal to 0. Then I find this and I give my system. Now let's output this and see. This is referred to as inline. It is part of this equation. Let me just type something more. In order to solve this part, that is equation, we this number of steps, we increase the integrate factorization, computing the square, computing the square, and the quadratic formula. So let me ask you this. So you see that this is part of the sentence. When I ask you this, it's what I'll get on the right hand side. So now let me see how it has fitting. Let me zoom in for you to see. So you can see a squared plus b plus c is equal to 0. How it has been displayed so nicely. Let me just see it so that you see it. So you see so nicely. I tried in on this left hand side, but I output it so nicely on the right hand side. That is the power of Latex. I'm going to try some more equations. So let me just create it and then zoom it in and finish out. Okay, you can see. Now, let me continue with what I'm trying. So quadratic formula. If I want to move to the next line, I create some space, I'll just use it. Means whether I've ended the line or not, I want to move to the next. So I'll move to the next one. So I can even bring another one to further proof this is done. The quadratic formula formula is given by, so this time I'm going to use an equation environment. And the equation environment, one of them is to use what we learned, the square bracket, backslash square bracket, backslash. So I just come to this line and do that. Backslash square bracket. So once I do that, it gives me the space. Then I type the quadratic formula. You know the quadratic formula is given as x is equal to minus b plus or minus square root of a squared minus 4ac all over 2a. This is a common formula we all know. We call it the Almighty formula. I don't know how Almighty this formula is. Anyway. So I'm going to type that formula using all that we have learned. So pay attention and see how it is done. I begin by typing my x is equal to minus b. Now remember, minus b, blah, 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 they are all in fractions. That's the minus b aspect is the numerator, and then all over 2a is the denominator. So I have to begin with a fraction. Frac, sorry, frac. Then the moment you type frac, you see the frac intelligence there. So don't finish typing it, just select it to give you the structure or the format. Then you just type in the numerator and the denominator. That's all. So frac minus b is plus or minus. If you have forgotten the keyword or the command for plus or minus, come to the side here. The symbols are here. So the one that looks like a star, that's where the symbols are. You click on it, and you can even pull this one to this side to see. You can adjust the screen. Let me adjust this one. So when you adjust the screen, you can see a lot of the symbols. And then you can click on the one that you want, plus or minus. So you see plus or minus here. The actual keyword is backslash PM. Then when you click on the symbol, it will insert backslash here. So please watch here, where minus B is here. You're going to click plus or minus B here. So PM is inserted. Right. So plus or minus backslash square root. So R B, so it comes. You just select it. Use the tab. Once you select it, then whatever you want to come under the square root is type. So b square is just a single character 2, so I don't need to put it into bracket. Minus 4ac, so that I'm done with the numerator. Then I go to the denominator. I double click to select whatever is there and I apply it. Then I type my numerator. So 2a, that's all. So I'm done with my quadratic formula. If nothing is underlined, if I have a mistake, it should be underlined. For example, if I insert square root, I insert e here, it will highlight it or underline it. So that will tell you that something is wrong with the syntax. So once you do this, I can run it and see. Look at the right hand side. Let me drag it and blow it up for you. So now see, my square root is there nicely. See, it's so nice. And this is sometimes how when you try you see in this I'm so nice. Okay. Let me increase the zoom so that you can see. So this is what we refer to as the block equation. There are other ways of typing the block equation. You can use double dollar sign or you can use the equation environment. If you use this, it will not add equation number to it. But if you use the equation environment, it will add equation number to it to make this one like equation one, that kind of thing. So let me use some of them and see how it is done. So I will type some equations here and for you to see how the equations type. So this is one way of typing this equation. Coming to type another equation. The to describe describe the type of root of the equation, we use the discriminant, which is given by, then I am going to use another block equation, the discriminant. So I use the double dollar sign. Double dollar sign is also another way of specifying equation environment. So we have this and another double dollar sign to end it. So you put your equation in the middle. So we have, let's say g is equal to similar g square minus 4a6. That's my exponent. This one too will not give it equation number, but it will just give it an equation environment. So let me run it and see the 90. What the backslash square bracket can be double dollar sign. Then we have a third one, which is the equation environment. That one gives you the equation number. Uh, some packages want to install, which I don't want to cancel. Okay, I'm going to still continue my narration. Example. So we also have example as you know, example as an environment. But I just want to just use the example something simple. Later on, we can look at that. Example. So the following quadratic quadratic equation. Okay. Then I'm going to use equation environment to type the equation. Just to let you know the various modes. So it's an environment that begin with backslash begin environment. So I choose begin environment. Then I type the environment name equation. And it gives me the full environment, the begin and the end environment. Then it's showing me that the content is coming. So then I'll type the content. So we have x square. Let's say I want to get some equation. So x square plus 10x plus 25 equals 0. So after that, a quadratic equation. I'm using some of these simple equations. Later, I'll type a very wild equation before I stop the video. So I type this, and then I ended it. Let's output this and see how it looks. Let me see. Once nothing is underlined or highlighted, I'm on pause. So I run it. When I run it, you can see the equation coming. So you can see the example. Solve the following quadratic equation. Then equation comes. And this is equation 1.1. 1.1 because I am using chapter 1. So using chapter 1 to label all my equations. It means the next one will be 1.2, 1.3, and that's what. But it doesn't use the section number. It uses the chapter number. Okay. If there's no chapter, if you just make it equation 1. So that is. So I told you that you can indicate the equation now. If I don't want the numbering and I still want to use the equation, I'll just come back here and say backslash no number. It will come just a little. And then when you run it, the number is okay. Then we use the no number for the equation array, not for this equation. So that's why it's not. Okay. All right. Okay. So when you get to equation array, I'll use that. So this is another way of typing equation. Now let me use equation array. Assuming we want to solve this equation. So solution. And solution, yeah, so let me just like solution. And under that, I will use equation array so that I can arrange the various things that I'm going to. Now, solving this equation, we know the two factors that multiply to give 25 is 5 and 5. And if you add them, you get 10 and that and that and that. So let's solve that equation. I use equation array. It, oh, sorry, begin environment. I have to begin the equation environment. And I type the environment. Equation, that's E-O-N array. Like if nothing is highlighted or underlined, I'm good to go. Normally, if there's a problem to highlight it red, for you to see, or pink or whatever color you have. So I clear the, and then I begin to solve. First of all, I type the equation. So let me just copy and paste. I can also copy and paste. I paste it here. And then, because I want all of them to align, I will use ampersand here, if you remember. And then ampersand there to flank or to shout the equal to sign. And then if I want to go to the next line, I will just have to type backslash, double backslash, means next line. And I'll put the enter key to go to the next one. Then I continue to solve. So the two factors are 5 and 5. So I begin to type x squared plus 5x plus 5x. Everybody knows in this class knows how to solve quadratic equation. Plus 25 is equal to, so I bring ampersand equal to ampersand. I want them to be arranged our line using the equal to sign equal to 0. Then I'll have my backslash. Then I continue to go x is the power. So this time I'm going to factorize. So I pull x out and I'm going to get x plus 5. And the other one will be plus. Then I pull 5 outside. I'll be left with x plus 5. And then remember ampersand. So ampersand equal to ampersand is equal to 0. Then I continue. So I have x to bracket, sorry, x plus into bracket x plus 5 or x plus 5 equal to ampersand. Ampersand is just to align the equal to sign so that they will be on the same vertical line. Then I begin to solve and say that x is equal to 5, so that is 1, then ampersand. So look at something, so the plus one, ampersand. Then I'm going to use mbox. That before I use mbox, I will just create some space. How do we create space? We use backslash colon. So as many space you want to create, you can use a space, because if you create a space like this, it doesn't recognize that. It will still put it together, whatever is coming, whatever you are going to add. So you don't use that to create space in the formula environment. You use the backslash. So I want more space, or I can just create this space. Then I want to type or, so I use mbox. Mbox. Then I type my or inside. I type my or inside, and then I go to the next. So this or will not emphasize or add highlight like the words in the equation environment. It will make it like a normal text because of the mbox. Then I come down here and I come and do the same. X equal to ampersand. Okay. So x is equal to 5 or x is equal to 5. Then I'm done with my equation. The last one, I don't need to bring and close this space. That is really helpful. Once I'm done, I stop using. You type it this way, it doesn't look nice, but when I output it, you say wow, and then the number is 90. So I run it, and then you can see that portions of it is gone to the next page. The next. You see how all of them are aligned. See the all, the space I created. If I had not brought these things, for example, let me clear it. You see that the all will attach to the 5. So I run it to see the all. It doesn't recognize even if I give the whole 1 yard space. It will not recognize that space. So if you want more space, you can in a formula environment, you can just put this. But this is not a formula environment, you don't need it. So as much space as you need, you can use it. And the numbering should be there. See the number. Now if I don't want a particular number, for example, I want the first one, I don't want the second one, and I want the third one. I can just come here. It will come here, I type, or Let me check. Rather be after all. Okay, let me do all these things. Uh, mm, no number. So let me do that. If it doesn't give me, I'll just put it. I know it's either inside or outside. So, so the second one, second equation is up here. Okay, if I come down. You realize that where I'm putting it is right. Realize that the second equation is not having any underline, any numbering. The first equation is up here. Okay. And remember, the so this is the first equation. This is the second. Oh, okay. Because I put it after, so it should rather be here. That's why it has affected the third one. It should be inside. Okay. To affect the second one. This is the second one. So I put it here, and then the second one goes there. So if you don't need any numbering for a particular equation, just say no number, and that one will go. If I don't want numbers for the last one, I just come here and just copy and paste, and then I paste it, and then I run it, and the number. So what did I say? Oh, I think we are the last but one. So there it is. I'm just gonna say so it's gone. If I bring it here, you see the green is the last one is here. So, so this is how you manipulate the equation. You realize that all the equations are aligned nicely. Right? So that is how we let me put this so that we can appreciate what we are doing. So this is the output of the Yama thing we are doing on the left hand side. This is how to use Latex. It is so wonderful if you know how to use it. And it's so easy to learn. I'm going to type one period equation for you to see how the Latex is used to type equation. So let me type one period mathematics equation. Let me get that. The following is a period period mathematics equation or formula or whatever or expression. And I'm going to use equation environment. So I begin my environment and I type equation and I clear the environment. If I use this, it means I want to number it. But if I don't want it, I can use the double dollar or the square bracket, backslash square bracket, open and close. I'm going to type an integral with some wow stuff. So if you want to type integral, you use backslash int. And then the integral, if it has limits, upper and lower limits, then you choose, look at the intelligence. You choose the second one, which has the minimum maximum. You choose it. So that you can say integral starting from 0, okay, to, let's say, pi over 2. Pi, so how do you type pi? Pi, and remember I'm saying pi over 2, so I need to put a fraction there before I bring the pi as numerator. Pi, so frac, oh, frac, then I choose the pi, which will be on top, and then the over 2 will be down. This is just the limit. Then whatever I want to be in the integral, I type it. So run, if I run this, you see the integral sign. Let me run it for you. Look at the left hand side. Going to so you see the integral sign. Let me blow it up a little bit. Oh, I didn't bring the backslash here. That's why the pi is showing as normal pi. Here, I correct it. So you can see nicely. And let me type some wild equations in front of it. So I'm going to type a fraction, frac, and then at the top, I'll type some exponential e root, sorry, e raised the power x raised the power, so the e raised the power has also x raised the power 3 plus x of 5x minus 2. That is only the power for the e. So this one is the exponent and it's still at the numerator. So I come after the bracket of the numerator, bracket of the exponent, and I continue to type any expression that I want. After all, I'm typing expression. So plus, let me close this one. Get more. So plus lane, and lane is also lane. Uh, put it into lane. What's lane? What? X or 10 x minus 4. Okay, and then that one should be in bracket. So let me put them in bracket. Oh, I should have typed the first bracket. Okay, so this thing is another. So that is the numerator. Then